Okay, now problem number 8, it says that you run the only lemonade stand, of course, in Central Park. If people don't buy lemonade from you, their only other option is to buy orange juice from a nearby vendor. So, there is a stand that of orange juice, of lemonade in Central Park, sorry. And if people don't buy from your stand, then their other option, of course, to buy orange juice from another vendor. One day you decide to raise the price of your lemonade from $1 per glass to 1.25 dollars per glass. Okay? As a result, half of your usual customers decide to get orange juice. That means you lost 50% of your customers. 50% of the quantity demanded of your lemonade, has been reduced. Now the question, calculate the price elasticity of demand for lemonade as the price increases from 1 to 1.25. So the coefficient of the price elasticity of demand is equal to the percentage change in the quantity demanded of the good over the percentage change in the price. Okay, the percentage change in the quantity demand of lemonade, of course, he wants to talk about the price elasticity of demand for lemonade. It is 50%. So here, the percentage change in the quantity demand of lemonade is what? 50%, minus 50%, because there has been a decrease of 50% of the demand of orange juice. 50% of the quantity demand of 50% of the quantity demand of lemonade has been reduced. Therefore, the percentage in the quantity demand of lemonade is minus 50%. Now, what about the percentage in the price? We know that the price has increased from $1 per glass to $1.25 per glass. Therefore, the percentage change in the price is equal, of course, as you can see, is which is the formula. We just apply this one. As you can see, we get 1.25 minus 1 over the average, of course, the change in the price over the price average times 100, and we come up with 22.2%. This is the percentage change in the price of lemonade. Now, we just plug these numbers, okay, in the equation of the coefficient of the price elasticity of demand. When we come up with, of course, we remember that when we calculate the coefficient of the price elasticity of demand, we take the absolute value, so we'll always have positive value. So now we get 2.25. We get the absolute value here. Okay, we cancel out the percentages, and we get 50 over 2.2. We get 2.25. Okay, this is the coefficient of the price elasticity of demand of lemonade. Now, the question 2 says, what does this experience tell you about the demand for lemonade in Central Park? So we look at the value of the coefficient. It is greater than 1. As you can see, it is greater than 1. Therefore, it is elastic. So of course, lemonade, the demand for lemonade in Central Park is elastic. Why? Because the coefficient of the price elasticity of demand is greater than 1. Now we move to question 3. It says, what would happen to your total revenue, TR, total revenue, as you increase the price of lemonade from $1 to 1.25? Remember, now we know that the demand of lemonade is what? is elastic. So when the price increases, then the expectation is that the quant demanded will decrease. And so total revenue will follow the quant demanded. Since the quant demand decreases, then total revenue will decrease. Total revenue, of course, will decrease. Okay, and it's discussed over here. Part 4, of course, what will be the sign of the cross elasticity between lemonade and orange juice? Why? Of course, as you can see from the question here, that the other option of customers when the price of lemonade increases is to go to another vendor who sells, orange juice. Therefore, orange juice is a substitute of lemonade. Okay, therefore, since they are substitute, then the expectation is that the cross elasticity between lemonade and orange juice is positive. Okay, and it is, of course, discussed over here. Now, 5, assuming that half your customers went to the orange juice stand. That's when you increased the price of lemonade from $1 to 1.25 cents. Half of your customers went to the orange juice stand. Consequently, the quant demand for orange juice has increased by 30%. Okay, of course, the quant demand of lemonade has decreased by perhaps 50%. But now here is telling you that the quant demand of orange juice has increased by 30%. Calculate the cross price elasticity of demand between lemonade and orange juice. So now we need to calculate the coefficient of the price of the cross price elasticity of demand between lemonade and orange juice. We know that they are substitutes, and we know that the coefficient is positive. Okay? The question basically, implicitly tell you this. Now, we need to calculate the coefficient of the cross price elasticity of demand. Of course, we plug the values in the equation of or in the formula of the cross elasticity demand, which is equal the percentage change in the quant demand of orange juice over the percentage in the price of lemonade. We know the percentage in the quant demand of orange juice, which is what? 30%. It's positive, 30%, because it's telling you here that there is an increase of 30% of orange juice. So we put 30% over the percentage in the price of lemonade. We know from here, we have already calculated the percentage in the price of lemonade from here, from the question number 1, which is 22.2%. Okay? And we plug the value over here in the formula of the cross elasticity of demand between orange juice and lemonade, and we come up with 1.35, which is greater than 0. Therefore, as you can see, this, the coefficient of the cross elasticity demand shows that lemonade and orange juice, are substitutes. Now we move to question or problem number 9. Problem number 9 consists of 2 parts, 1 and 2, of course. Part 1 says calculate the cross elasticity of demand and determine whether the goods are substitutes or complements. When we calculate the cross elasticity demand, if the coefficient of the cross elasticity demand is positive, then we say the goods in question are substitutes. And if, on the other hand, if the cross or the coefficient of the cross elasticity demand is negative, then we say the goods are complements. Okay, so if Px1 equal 10, the initial price of x1 is 10, the quant demand of y1 is 100, Px2 is 12, and quant demand of y2 is 114. As you can see, price of x increases from 10 to 12, and the quant demand also increases from 100 to 114. So in order to make sure that, the goods, it looks that they are substitutes because, as the price increases, the quantity also demanded increases. But let us verify this by calculating the equation of the cross elasticity of demand. As you can see, this is the equation. EC, the cross elasticity of demand between x and y, is that the percentage in the quant demanded, of course, of y over the percentage change in the price of x. Why? Because the price of good x changes, and the quantity of good Y changes. Therefore, the cost elasticity of demand is the percentage change in the quantity demand of Y over the percentage change in the price of X. And when we calculate the percentage in the quantity demand of Y, we come up with 130.8%. And when we calculate the percentage in the price of X, then we come up 18.8%. We plug these values in the formula of the cost elasticity of demand here, and we come up with 7.19%, which is greater than 0. Therefore, the goods are substitutes. Now, the second part of the question, calculate the income elasticity of demand and determine whether the good in question is, of course, normal or inferior. Now, let us just remind you of the meaning of an inferior good or a normal good. A good is an inferior good if, income increases, then the quantity demand of it will decrease. When your income increase, it is quantity demand of that good will decrease, okay? And a good is normal if, your income increase, then the demand of that good will increase, or the quantity demand of that good will increase. This is basically the, the basic definition of an inferior good or a normal good. So here we look, of course, we have a quantity demanded, the initial quantity demand of the good is 8, and the final quantity demanded of the good is 15, so it increased. Now the initial income, Y, denotes income, is Y1 is 1,000, the final income is 800. So as you can see, income decreased, okay? Income decreased. However, the quantity demanded increased, okay? When income decreased and the quantity demanded of the good increased, that means implicitly that the good is inferior, okay? The good is inferior. Why? Because when your income decreases, therefore, you tend to purchase the goods that are cheaper, the goods that are inferior. So this is an inferior good. But let's, verify this by calculating the formula of the, income elasticity of demand. This is the formula here, as you can see. EI is the percent change in quantity demand over the percent change in income. Y denotes income. And when we calculate the percent change in the quantity demanded, okay, we come up with 60.9%. And the percent change in income, we come up with minus 22.22%. Okay, this is the formula for the percent change in income, which is change in income over the, the income average, which is this one here. And we come up with this. We plug these values in the equation, as you can see, here. So we come up 60.9% over minus 22.22%. We come up with the, the result is minus 2.74, okay? So, which is negative. So when the value of the income elasticity, of demand is negative, then this will give us, this means that the good in question is an inferior good. So when the income elasticity of demand is positive, then we say the good is normal good or superior good. And when the income elasticity of demand, the coefficient of the income elasticity of demand is negative, then the good is an inferior good. Okay? Now we move to problem number 10. Number 10, it says, given two goods, X and Y, okay, such that good X is an inferior good, and good Y is a normal good. The demand curves for both goods are shown below, okay, shown below. The demand goods for both goods are shown, of course, below. Now, and the initial demand for any of the goods, is D1. So D1 is the initial demand for good, for the inferior good, and for the normal good, for good X and good Y. Good X is a inferior good and good Y is a normal good. As you can see, D1 shift to the left here from D1 to D2 for the case of X, good X, which is the inferior good. However, D1 shift to the right, okay, for the case of the normal good. Okay, so we know now that good X is inferior good, good Y is a normal good. The initial, demand curve for both is D1. And now the question number one, it says the shift in D1 and D2 are due, the shift in D1 and D2 are due to change of income. Okay? Now, what happens to the income as the demand of both goods shifted from D1 to D2? Okay? Now, as you can see, the shift in D1 and D2 is due to income. Due to income. Now, the question is that what happens to the income? Income has a change, okay? Was an increase or decrease? And as a result of this, D1 changes, okay? Therefore, what happens to the income as the demand of both goods shifted from D1 to D2? Now look over here. For this case, for D1, for the good X, D1 here, as you can see, shifted from to the left, from D1 to D2. Because good X is an inferior good, the only way for income to change either to the right or to increase or decrease, and D1 to shift to the left, that is the quantity demand to decrease, is that when income increases. When income increases, then the demand for the inferior good will shift to the left. That is, the quantity demand of the inferior good will decrease. Okay? So here, for D1, of course, shifted to the left as a result of the increase in income. Okay? As a result of the increase in income. Okay? Now, what about here for the case of good Y, which is a normal good? As you can see, D1 shift to the right. So, which implies the quantity demanded of good Y increased. So, this means that income has increased. So, when income increases, then the demand for the normal good will increase. As your income increases, of course, you tend to purchase more of normal goods. Therefore, since D1 shift to the right, that implies the quantity demand of good Y increase, which means that income has increased. So as you can see, in both goods, good X and good Y, income has increased. However, D1 for the case of the inferior good has shifted to the left because income increased, and D1 has shifted to the right for the case of good Y, which is a normal good because income increased. Okay? Now, part 2, or the question 2, the individuals are only consuming X and Y. The individuals are only consuming X and Y. Along D1 for both goods, this D1 here, what is the level of income if Px and Py are the same? Px and Py along here, let me repeat the question again. The individuals are only consuming X and Y. Along D1, this is D1 here for good X and D1 here for good Y. Along D1, for both goods, X and Y, what is the level of income, okay, if Px and Py are the same? Px 4, along D1, 4, and here 4. So, price 4 for good Y, and the price 4 for, of course, good X. Now, what is the level of income? In other words, what is saying here, what is the level of expenditure or spending for, of course, for good X, for consuming good X and Y. Now, as you can see, along D1, if the price is saying if PX and B are the same for, then along D1, the quantity demanded is 18. So along D1, the level of expenditure or level of income, devoted to the good X along D1 is 4 times 18, which is, 72. Now along D1, okay, for good Y, or the long D1 for good Y, the level of income or the level of expenditure is going to be equal to 4 times 6, which is 24. So, as you can see, along D1 and D2, for both goods, the level of income or the total level of expenditure for both goods is going to be equal 72 here plus 24, which is equal $96. So $96 is the level of income, of course, for consuming X and Y, for consuming both X and Y. Now, 3, calculate cross elasticity of demand between X and Y as the price of X increases from 4 to 6, and the quantity demanded of Y increases from 6 to 9. There is some kind of influence. Good X and good Y are, related in this case. When the price of good X changes, the quantity demand of good Y changes. Therefore, both goods are related. There is some kind of relationship between them. So here we need to find out whether they are complement or substitutes by calculating the cross elasticity of demand. So the cross elasticity of demand, this is the formula for it. This is the formula for the cross elasticity of demand, as you can see. When I play with this one here and, simplify it, I will come up with, from this to this. So this is an easier, formula for the cross elasticity of demand, which is equal QY2 minus QY1 over QY1 plus QY2 times PX1 plus PX2 over PX2 minus PX1. I think I have, derived this one when I discussed the material just a while ago. When I was discussing the material in this chapter. So when I plug the values over here, we come up, QY2, the quantity demand of Y2, as you can see, 9 minus 6 over 6 plus 9 times the price of X1 plus the price of X2, price of X1 4 plus 6 over 6 minus 4, and when I plug them, I get with 1. So here, as you can see, the cross elasticity is positive, is 1 positive. So I could say here that good X and good Y, are substitutes. Why? Because it is positive, greater than 1. So they are substitutes. Okay? Okay, now we move to discuss and solve problem 11. It says determine the type of elasticity for each of the following. So we have here 3 questions. We need to determine whether each one is elastic or inelastic or unitary or perfectly elastic, and so on and so forth. The first one, it says price rises by 10% and quantity demanded falls by 2%. Remember the definition of a demand that is elastic. Demand is elastic when the coefficient of the price elasticity of demand is greater than 1. and the equation of the elasticity or the price elasticity of demand is that the percentage change in the quantity demanded over the percentage change in the price. So the percentage change in the quantity demand is 2%, minus 2%, okay? And the percentage change in the price is 10%. So we just substitute the values and make sure to take the absolute value because eventually we're going to have a positive value, okay? Or 0. So when we do that, we come up with 2 over 10, and 2 over 10 is less than 1, which means that we have an inelastic demand. Part 2 or question 2, price falls by 2% and quantity demanded rises by 2%. So as you can see, a price decreases by 2% and the quantity demanded, of course, increases by 2%. The law of demand, when the price increases, the quantity demanded falls and vice versa. So here, the price changes by 2% and the quantity demanded changes by 2%. So therefore, when you plug the values, you come up with 1. Okay? So what you have unit elastic. Okay? Unitary. Demand is not elastic. Now what about 3? 3 says price rises by 6% and the quantity demanded stays constant. So quantity demand stays constant. So what you do, 0. So quantity demand stays like 6%, 6 or 7 or 8. It's constant. So when you take the change, the percentage change, you come up with 0. Okay. So we get 0. Plug that. EP is the elasticity, price elasticity of demand. Is 0% over 6%. You get 0 over 6. You get 0, and that is perfectly inelastic. And the curve or the demand curve that corresponds to this is going to be vertical. Now, problem 12, it says, of course, here 13. Problem 12 says, determine if total revenue falls, rises, or stays the same for each of the following. We're going to see whether total revenue increases, decreases, or stays the same. Okay? Of course, depending on the rules we have already mentioned when we discuss the material in this chapter. Remember here, demand is inelastic. Demand is inelastic. That means the coefficient of price elasticity of demand is less than 1. Great. And the price rises. So if demand is inelastic and the price rises, then total revenue will increase. Why? Because total revenue in this case will follow the price. So the price increases, therefore total revenue will increase. 2, demand is elastic and the price rises. Demand is elastic. That means the coefficient of price elasticity of demand is greater than 1. And so for this type of demand, in order for total revenue to increase, the price should decrease. Here the price rises, therefore total revenue will decrease because total revenue in the range of elastic demand, will follow the quantity demanded. Here in this, the quantity demand will fall because the price rises, therefore total revenue will fall or will decrease. Now, 3, demand is elastic and the price falls. So here, exactly as I said, total revenue will increase. Why? Because demand is elastic and price falls, therefore total revenue will increase. Total revenue will follow the quantity demanded. When the price falls, that means quantity demand will increase, so total revenue will follow the quantity demanded, and so total revenue will increase. 4, demand is unitary and the price falls. Demand is unitary and the price falls. You remember, when demand is unitary, okay, or unit elastic, that means a change in the price, whether increase or decrease, will cause total revenue to stay the same. No change in total revenue, okay? No change in total revenue. Now, we go to problem 13. Problem 13 says, given the following demand equation, as you can see, P is equal to 200 minus 30Q, where P is the price and Q is the quantity demanded. Now, he says, calculate part 1 of the question, calculate the price elasticity of demand if the price increases from $100 to $160. So here we know the price. So we need to find the corresponding, quantities, we have to calculate or solve this equation for Q in terms of P and plug for each, the price. Okay, so when we do that, we come up with Q equal 20 over 3 minus 1 over 30P. Okay, great. So now, when P equal 100, you plug 100 in P over here, and you come up with the value of Q. The Q is 3.3. When P equal 160, all you have to do, plug 160 over here, and just, simplify it. And when you do that, you come up with 1.3. So now we just use the formula of the price elasticity of demand. I just simplified that formula, okay? This is the formula, percent share equal demanded over percent share in the price, okay? And then which is equal Q2 minus Q1 over Q1 plus Q2 times P1 plus P2 over P2 minus P1. This is a very simplified way to calculate the price elasticity of demand. And when you do that, plug the formula over here, of course, plug those values, okay, in this, a simplified equation of the price elasticity of demand, and you come up with, of course, EP or the price elasticity of demand equal, of course, 1.84, which is greater than 1, it is elastic. Now, what happens to total revenue, TR, total revenue, as the price increases? Okay, since we know that it is elastic, then when the price increases in the elastic, when the demand is elastic, then total revenue, of course, will decrease. Total revenue will decrease because total revenue follows the quant demanded. And when the price increases, total quant demand will fall. Therefore, total revenue will fall. That is, it will decrease. Now, 3, verify your answer by calculating total revenue. So in order to verify, to make sure that what we, determine here in part 2 is right, let's, use the total revenue test. Of course, when price equal 100, okay, the quant demanded is what? Is 3.3. So total revenue, TR1, is 100 times 3.3. We get what? 330. Okay? 330. Now, when price equal 160, quant demand is 1.3. So total revenue, 160 times 1.3, okay, is equal to 208. As you can see, so here, as we say here, total revenue decreases from 330 to 208.